Let's see what happens when you raise to powers that are fractions. For example, what's 9 to the 1/2 power? But before we dive into fractional powers, suppose you're raising 9 to the 4th, and then you raise that to the 5th power. This equals 9 raised to another power. What's the missing exponent here? Exactly. Whenever you raise a power to another power, you can multiply the exponents together. So 4 times 5 equals 20, meaning 9 to the 4th raised to the 5th equals 9 to the 20th. Great, so let's return to 9 raised to the 1/2 power. To figure out what this equals, let's square it, meaning we're raising it to the 2nd power. This equals 9 raised to another power. Try using the same trick of multiplying the exponents to figure out the value of this missing exponent. Right, 1/2 times 2 equals 1, so this equals 9 to the 1st power. And any number raised to the 1st power is just that number, so this equals 9. Interesting. So whatever 9 to the 1/2 is, when you square it, you get 9. Now what other number can you square to get 9? Precisely, 3 squared equals 9. And that's because 3 is the square root of 9. Remember that square roots and squares cancel out, just like the exponents of 1/2 and 2 over here. So these two expressions here mean the same thing. In general, raising to the 1/2 power is the same thing as taking a square root. So next, try evaluating these three expressions. For this one down here, give your answer to 2 decimal places, and you might want to use a calculator. Nicely done. 25 to the 1/2 power is the square root of 25, or 5. 1 to the 1/2 is the square root of 1, or 1, and 2 to the 1/2 is the square root of 2, which is approximately 1.41421, and so on. Next, what about raising a number to the 1/3 power? Well, starting with 8 to the 1/3, let's then raise it to the 3rd power. This expression equals 8 raised to another power. So once again, find the missing exponent. Exactly, 1/3 times 3 equals 1. So this is 8 to the 1st power, or 8. So whatever 8 to the 1/3 is, when you cube it, you get 8. What other number can you cube to get 8? Right, cubing 2 gives you 8. In other words, 2 is the cube root of 8. So 8 to the 1/3 power is the same thing as the cube root of 8. So in general, raising a number to the 1/3 power is the same as taking a cube root. Try using this fact to evaluate 64 to the 1/3 and 0 to the 1/3. Nicely done. 64 to the 1/3 is the cube root of 64, or 4, while 0 to the 1/3 is the cube root of 0, which is 0. So you probably see a pattern here. Sure enough, raising to the 1/4 is the same as taking a 4th root, raising to the 1/5 is the same as taking a 5th root, and so on. So next, what's 243 to the 0.2? To get started here, you might want to rewrite 0.2 as a fraction. Nicely done. 0.2 equals 1/5. So 243 to the 0.2 is the same thing as 243 to the 1/5, which is then the 5th root of 243, or 3. So for your final challenge, suppose you're asked to find the 4th root of 137. The answer here is not a whole number, so you'll want to use the calculator and give your answer to 2 decimal places. But hold on, if you look at the calculator, there's a button for finding square roots, but there's no button for finding 4th roots. So what can you do? Maybe there's a clever way to raise 137 to a certain power to find your answer. Brilliant! The 4th root of 137 is the same thing as 137 raised to the 1/4 power. So on the calculator, you can type in 137 and then raise it to the 1/4 power. you could also have raised it to 0.25 and gotten the same answer. So this equals about 3.42. So this is the fourth root of 137. Who needs a button for fourth roots when you can raise to a fraction or decimal power, right? So to summarize, raising to a power of 1 over a number, like 1 over 4 or 1 over 5, is the same as taking that root. Now you might be wondering what happens when you raise to a fraction that doesn't have a 1 in the numerator, like raising to the 2/3. Well, don't worry. You'll discover how to evaluate expressions like 8 to the 2/3 in a later lesson. Here we'll explore how to evaluate all sorts of fractional powers, like 8 to the 2/3. But first, what's 8 to the 1/3 power? If you're not sure, click down here to review raising to powers with a 1 in the numerator, like 1/2 and 1/3. Right, raising to the 1/3 power is the same as taking the cube root. So 8 to the 1/3 equals the cube root of 8, which equals 2. Next, let's look at 8 to the 2/3 again. Which of these expressions down here are equal to 8 to the 2/3? Exactly. Whenever you raise to a power and then to another power, that's the same thing as raising to the product of the two exponents. 2/3 is equal to 1/3 times 2, and it's also equal to 2 times 1/3. So both of these expressions are equivalent to 8 to the 2/3. So try evaluating these two expressions. What's 8 to the 1/3 then squared? And what's 8 squared then raised to the 1/3? Nicely done. 8 to the 1/3 is 2, so this is 2 squared, or 4. And down here, 8 squared is 64, and 64 to the 1/3 is the cube root of 64, or 4. So great! Both of these expressions give you the same result, just as you'd expect. And that means 8 to the 2/3 equals 4. So here's the general rule for evaluating fractional powers. Take the base, raise it to the power of the numerator, and then take the denominator's root. So 8 to the 2/3 means take 8, raise it to the second, and then take the third root. And you can also do it the other way around. First, take the third root of 8, and then raise it to the second. Either way, you'll get the correct answer, 4. For your next challenge, try evaluating these three fractional powers down here. Excellent! The fourth root of 16 is 2, and then cubing gives you 8. The fifth root of 243 is 3, and then squaring gives you 9. And if you start with 1, raising to the 13th and then taking the 17th root still gives you 1. Let's quickly look at decimal powers, like 10 to the 2.489. Well, this is actually a fractional power as well. Which of these expressions equals 10 to the 2.489? Precisely, 2.489 is the same thing as 2,489 divided by 1,000. So whenever you see a decimal exponent, you can also think of it as a fractional exponent. So how would you evaluate this? Raising to the 2,489th power and taking the 1,000th root seems pretty tough. So instead, try using the calculator to evaluate this expression and round your answer to 2 decimal places. So using a calculator, you can see that 10 to the 2.489 is approximately 308.32. So just to review, raising a number to a fractional power is the same as raising it to the numerator and then taking the denominator's root. And you also saw how the calculator can help you evaluate these kinds of powers.